Good day, grade 12s. My name is Motlengwa Tulang, and we will be doing our sequence and series for the day. Sequence and series is an important topic of our grade 12 exam. It contains plus or minus 25 marks in our examination that will be coming up later in the year. We are going to start with our sequence and series. A sequence is a set of numbers that are written in particular order, and each number in a sequence is called a term. A sequence is a set of numbers that are written in particular order, and each term or each number in that sequence is called a term. We have different types, or under the sequences we have types of sequences. It's either a sequence can be a finite sequence or an infinite sequence. Let's have, for example, a sequence that is a finite sequence. We can have 1, 3, 5, 7, and so on. These 3 dots, this is a sequence. This is a set of numbers that follows a certain trend. 1, 3, 5, 7, and after this 7 we have the 3 dots. That shows that this sequence continues up to infinity. This sequence continues up to infinity. The sequence is an infinite sequence. And then we can also have a sequence that is a finite sequence, whereby now we can have 1, 3, 5, and 7. This 7 here becomes the last term of this sequence here. Remember, we said a sequence is a set of numbers written in particular order, and each number in a sequence is called a term. In this case, we have 4 terms, which are 1, 3, 5, and 7. In this first one there, we have 4 terms that are visible there, but because of the 3 dots there, it shows that our sequence continues. And then again, our infinite sequence can also be represented as 1, 3, 5, 7, and then we have the 3 dots there, and then the last term can be shown as n. This sequence continues up to the last term. We have the last term there, the last term there is n, but in this first one there we don't have the last term, hence the 3 dots. This is our type of sequence. It's either a finite sequence or an infinite sequence. Under this sequence and series, we have 2 types of sequences. We have arithmetic sequence. We also have our geometric sequence. Arithmetic sequence, we started with arithmetic sequence back in grade 10, if you can recall. In grade 10, we had an arithmetic sequence, whereby now an arithmetic sequence was a sequence that only has a first difference that is constant. Our first sequence would be arithmetic sequence. Arithmetic sequence has the general term or the nth term or the general rule that generalizes everything that happens under this arithmetic sequence. And the general term or the general rule for the arithmetic sequence becomes Tn, that is equals to a plus n minus 1 multiplied by d. Tn is equals to a plus n minus 1 multiplied by d. We have the variables here. We have Tn, we have a, we have n, we also have d. These 4 variables mean 4 different things in our sequence, whereby now our Tn represents the term value, or the nth term. Some books might say it's the general term. It's called the term value, the nth term, or the general term. That is our Tn. And we also have a. A in all the sequences that falls under arithmetic sequence, A stands for the first term. A stands for the first term, meaning that if we have a sequence, like for instance the sequence that we had above here, 1 3 5 7, if this is our sequence, the first term there, which is 1, that would be our value of A, meaning that in this sequence here, A is 1. And then we also have N. N represents the term number. N represents the term number. Term number would be N. And then the last one would be D. D is our common difference, or some books might say it's the constant difference. This common and constant difference, they mean the same thing. It's called the common difference or the constant difference. Let's have, for example, the first sequence that we had above there, whereby the sequence said the sequence was 1 3 5 and 7. If this is our sequence 1 3 5 and 7, and we are requested to find the general term of this sequence, or what type of a sequence is this, and then for us to identify this sequence, for it to be an arithmetic sequence, it only has to have one difference that is constant. It doesn't have to have many differences. It needs one difference that is constant. And from earlier grades, we know that a difference is a minus. We only have a difference when we minus or subtract two terms. Now, in order for us to have the common difference, our common difference would be equals to term number 2 minus term number 1. That must be equals to term number 3 minus term number 2, and so forth. If this is common, it means that it is constant. Hence, we equate the two. Term number 2 minus term number 1, it must be equals to term number 3 minus term number 2. Now let's check whether this sequence forms or falls under our arithmetic sequence. Let's check the first difference there. For us, we are going to say 7 minus 2, or 7 minus 5, that gives us 2. And then 5 minus 3 also gives us 2, and then 3 minus 1 also gives us 2. Hence, we now have one difference there, that is positive 2, and then this sequence is an arithmetic sequence. For us to find the general term of this sequence, we are going to say Tn, that is that general term that we have there. Tn is equals to A plus n minus 1 by D. And then our A, we said A is the first term of this sequence. A, the first term there is 1. Therefore, A is 1 plus n minus 1. We are looking for the nth term, or the general term of that sequence. Hence, we don't have this Tn. We are looking for the value of Tn. And then the difference, or the constant difference that we had there is the difference there. It's positive 2. We multiply n minus 1 by 2, and then getting rid of the brackets there, we are going to have 2n my 2 multiplied by negative 1 gives us negative 2, and then negative 2 plus 1 would give us negative 1. This is the nth term of this sequence there, 1 3 5 and 7. The nth term there is 2n minus 1. Okay, for instance, if we are again requested to find term number 50, term number 50. If you are requested to find term number 50, this is the term number. We are looking for the term value. We have the term number 50, and then we are requested to find the value of term number 50. In this instance, we are going to substitute 50 where we see n. That would be T50, that is equals to 2 multiplied by 50 minus 1, and then term number 50 would be equals to 2 multiplied by 50, it's 100. 100 minus 1 would give us 99. Therefore, term number 50 has the value of 99. Term number 50 is equals to 99. And then let's have the first example under this arithmetic sequence. The first example under arithmetic sequence would be, there is the first sequence that we're given there. The question says, consider the arithmetic sequence 4, 9, 14, and 19. This is an infinite sequence because it has the 3 dots after the last term. Therefore, there are many other terms that comes after that term number 4, which is 19. And then the first question that we have there says, determine the general term of the above sequence. We are again told that this is an arithmetic sequence, and we are asked, or we are tasked to determine the general term. The general term or the nth term, they are one and the same thing. In this case, we are tasked to find the general term. Because this is an arithmetic sequence, the general term of an arithmetic sequence would be Tn, that is equals to a plus n minus 1 multiplied by d, whereby now a is the first term and then d is the constant difference between those terms that we have there. And then if we are to find the difference between the two, we'll say 19 minus 14 gives us 5, and then 14 minus 9 would also give us 5, and then 9 minus 4 would also give us 5. That means that we have the constant difference that is equals to 5. Therefore, we can now get, or we can now calculate the general term of that above sequence. Our a there is 4 plus n minus 1 by d. D, we set our constant difference is positive 5. And then get rid of the brackets there. If we are about to get rid of the brackets, we'd say 5 multiplied by n gives us 5n. 5 multiplied by negative 1 gives us negative 5. Negative 5 plus 4 would give us negative 1. Therefore, the general term of the sequence 4, 9, 14, and 19, the general term of that sequence would be 5n minus 1. That would be our general term. And then there comes the second question that says, find the value of the 50th term. Find the value of the 50th term. We now have the 50th term. We have n, the 50th term, meaning that our n is 50. We are looking, or we are finding the value of term number 50. When I get to term number 50, what would be the value that we have there in this sequence? In the sequence 4, 9, 14, 19. This is term number 4. What would be the value of term number 50 if this sequence continues up to term number 50? Because term number 4 it's 19, term number 3 it's 14, term number 2 it's 9, and term number 1 is 4. Now if we get to term number 50, what would be the value of that term there? This is the question. And then if we are about to do that, we have the value of n. Tn is equals to 5n minus 1. We have the general rule or the general term of that sequence there that says Tn is equals to 5n minus 1. We are given the term number. Remember when we started, we said n is the term number. We are given the term number there that is equals to 50. And then we are looking for the term value. Therefore, where we see n, we substitute 50. This would be 5 multiplied by 50 minus 1. 5 multiplied by 50 gives us 250. 250. If we subtract 1, we have 249. Therefore, when we get to term number 50, the value of that term number 50 there would be 249. That is the second one. And then the third one, the third question says, which term of the sequence will have the value of 164? Which term of the sequence will have the value of 164? The question is looking for the term number that would have the value of 164. 164 is given as the term value, meaning that our 164 there would be our Tn. We are given that Tn is 164, and then we are looking for the term number. And then we have again the general term or the nth term that says, our nth term says Tn is equals to 5n minus 1. And then we are in this instance given that the term value is 164. We are going to substitute this 164 where we see Tn, and then we would in this instance solve for n. Our Tn is 165, that is equals to 5n minus 1. And then the only unknown that we have here becomes n. Which term of the sequence? We are looking for this n. That would be the term number. And then if we transpose this -1 to this other side, it would become positive. Okay, in this, or it's 164, it's 164. The term value there is 164, not 165. If we transpose this, then it becomes 165, that is equals to 5n. And then we have 165, that is equals to 5n. We can divide both sides by this positive 5, the coefficient of n. Divide both sides by 5. If this side we divide by 5 and that side we divide by 5, 5 and 5 cancels. 5 goes into 165 33 times. Therefore, our n would be equals to 33. This means that term number 33 is equals to 164. Term number 33 is equals to 164. That would be the first example under our arithmetic sequence. And then the second example might be, which term of the sequence is equals to 80? The second example there would say, which term of the sequence -1, 2, 5, 8 would be equals to positive 80. The question there again states that which term, meaning that we are looking for n, would be equals to 80. 80 is the term value. The term value again is Tn, and then we have this sequence there, -1, 2, 5 and 8. In this instance, we are solving for n again, like we did in the previous example. Solving for n again, we have the we must first find the general term, and then the general term of an arithmetic sequence is Tn. The general term would be Tn, that is equals to a plus n minus 1 all multiplied by d. Our Tn, or the nth term, is given as 80. Therefore, this side here we have 80, that is equals to the first term. The first term of this sequence, the first term of this sequence is given as -1. Therefore, this is the value of a, and the difference between the two terms, the difference here, 8 minus 5 is 3, 5 minus 2 is 3, 2 minus -1 is also 3. Therefore, our constant difference, or the common difference there, would be positive 3. We have our A is -1. We have our D it's +3. We have our Tn, or the term value, it's +80. We are looking for N, the term number. And then if we are about to solve this, would say our A there is -1 plus n minus 1 by D. Our constant difference is +3. If we have this there, then we multiply. 3 multiplied by n gives us 3n, and then 3 multiplied by -1 gives us -3. -3 minus 1 gives us -4. Then we have 80, that is equals to 3n minus 4. And then if you transpose this -4 to this side, it would become +4. Therefore we now have 80 plus 4, that would give us 84, that is equals to 3n. 84 divided by 3, we divide both sides, got 3, and then our 84 divided by 3 would give us the value of n as 28. 84 divided by 3 is 28. Now that is basically that about our arithmetic sequence. That is that about our arithmetic sequence, but that is not the only sequence that we have. Arithmetic sequence is the first one, of which is the continuation from what we did in grade 10. And then the second type of a sequence would be our geometric or exponential sequence. The second one would be our geometric, or some books might say it's an exponential sequence. Geometric or exponential sequence. Now in this sequence, let's have a it is an exponential sequence, or the geometric sequence. Let's have this as an example for our geometric sequence, whereby now we have 2, we have 4, we have 8, we have 16, we have 32, and then this sequence continues as well. And then the difference between our geometric sequence and arithmetic sequence is that the geometric sequence doesn't have the constant difference. But what is it that the geometric sequence have that is different compared to our arithmetic sequence? Let's check. If we say 32 minus 16 would have 16. 16 minus 8 will have 8. 8 minus 4 we have 4. 4 minus 2 we have 2. Therefore the difference that we are getting there, it's not a constant difference. Hence this kind of a sequence cannot be called an arithmetic sequence. But if we divide the 2, 32 divided by 16 we have 2. 16 divided by 8 we also have 2. 8 divided by 4 we also have 2. 4 divided by 2, that is 2. And the minute we say divide by 32 divided by 16, it's 2. 16 divided by 8, it's 2. Therefore we are talking about a ratio. From the earlier grades, you know that division is a ratio, and then we are talking about the ratio in this case. Therefore our exponential or geometric sequence has a constant ratio that would be noted as a variable r. And also this exponential or geometric sequence has the nth term. The nth term of the geometric sequence is Tn, that is equals to AR to the power of n minus 1. This is the nth term of the geometric sequence. Tn is equals to AR to the power of n minus 1. Where in this case again Tn, it's also, or again it is the term value. and then our A, still again our A is the first term, and then our N, the term number, our N is the term number, and then our R becomes our constant ratio. How do we find this constant ratio? For us to have the constant ratio, we said 32 divided by 16, it's 2. We said 16 divided by 8, it's 2. Therefore, our constant ratio can be equals to term number 2 divided by term number 1. That must be equals to term number 3 divided by term number 2. For it to be constant, it has to be equal. For it to be common, it has to be equal. Term number 2 divided by term number 1 is equals to term number 3 divided by term number 2. That is how we find our constant ratio. Now let's say for this sequence that we have above there, 2, 4, 8, 16 and 32, let's say we are requested to find the general term or the nth term. Remember, Tn stands for the term value, general term, or the nth term. Tn is general term, nth term, or the term value. Let's say in this instance, for this sequence there, we are requested to find the general term, or before that we are requested to find the term that comes after 32. The term that comes after 32, or that would be term number 6. Term number 6. For us to find term number 6, we are going to do the we are going to repeat the trend that is happening in this sequence, the order of this sequence. We are going to continue with the same order for us to find the next term. The first term there, it's 2, and then it's 4, 8, and then we have 16, we have 32, and then what would be the other term after 32? For us to find 4, we said 2 multiplied by 2 gives us 4. If we are going in this direction, we multiply if we are going to the right, but if we are going back to the left hand side, we divide. Now 2 multiplied by 2, it's 4. 4 multiplied by 2, it's 8. 8 multiplied by 2, it's 16. And then 16 multiplied by 2, it's 32. Now 32 multiplied by 2 would give us the term that comes after 32, and then that term, that would be term number 6, would be equals to 64. That is the next term after 32. Going this direction, going to our right hand side, we multiply. But if we go back, or we are going to the left hand side, we divide in this geometric or exponential sequence. Now let's get the general term of this sequence. The general term or the nth term of the geometric sequence is Tn, that is equals to ar to the power of n minus 1, and then we are requested to find Tn, meaning we're requested to find the general term. What is it that we have for us to find the general term, or what is it that we need for us to find the general term? We need A, we need R. The general term must be in terms of n, meaning that n must be the variable there. N would be there for us to find the general term. A, the first term, we have A is 2. Therefore, where we see A, we substitute 2. 2 multiplied by the common ratio or the constant ratio. In this case, our constant ratio is positive 2. Therefore, it would be 2 multiplied by 2 all to the power of n minus 1. The common mistakes that we tend to do as our grade 12s, we tend to multiply these two terms. Remember, 2 multiplied by 2 to the power of n minus 1, it is not equals to 4 to the power of n minus 1, because we tend to multiply 2 multiplied by 2 and then we have 4. The two equations or the two expressions are not the same. 2 multiplied by 2 to the power of n minus 1 and 4 to the power of n minus 1 are not the same. This can be a multiplied by b to the power of n minus 1, and this can be b to the power of n minus 1. Therefore, the two are not the same. So please remember that you are not supposed to multiply these two terms, a and r. Please leave it as it is here. This would be your correct answer. 2 multiplied by 2 to the power of n minus 1. This is our geometric or exponential sequence. Now let's check the questions or the examples that we have under geometric or exponential equations. Now the first one that we have there would be our example number 4. Example number 4 there says consider the following sequence. The sequence that we have is -5, 10, -20 and 40. We are given the sequence -5, 10, -20 and 40, and we are told, or we are only told, that to consider that sequence. Now what type of a sequence is this? For you to find the nth term of any sequence, you need to first identify the type of that sequence, whether the sequence is arithmetic or the sequence is geometric, or in grade 11 the sequence might be quadratic, but in this case we are only dealing with arithmetic and geometric. So this sequence can either be arithmetic or geometric. Now let's check whether the sequence is arithmetic or geometric. The first term is -5, the second term is 10, the third term is -20, and then the other term there becomes 40. And then this sequence continues. For us to find whether the sequence is arithmetic, it has to have the constant difference. And how do we get the constant difference? Term number 2 minus term number 1, that must be equals to term number 3 minus term number 2. Then if that is correct, then the sequence would be arithmetic. Now for it to be geometric, the sequence has to have the constant or the common ratio. How do we find the common ratio? Term number 2 divided by term number 1, that must be equals to term number 3 divided by term number 2, and so forth, and those two ratios must be equal. Now let's start first here. Term number 4, it's 40. If we divide it by term number 2, which is, or term number 3, which is -20, 40 divided by -20, we are going to have -2, and then -20 divided by 10, we are again having -2. A positive 10 divided by -5, again we are having -2. Therefore our constant ratio here is -2. Therefore our r is -2. Now if we have r, we can find, therefore this is the geometric sequence because it has the constant ratio. Now the general term for the geometric sequence is Tn, that is equals to a r to the power of n minus 1. There is our sequence. Tn is equals to a r to the power of n minus 1. Our a, it's -5. Therefore we have -5. Because it's negative, I might need the brackets for that. -5, and then our r again is -2 to the power of n minus 1. N minus 1. Then this becomes the general term of the sequence: -5, 10, -20 and 40. The general term of that sequence is -5 multiplied by -2 to the power of n minus 1. Now, it's not always the case whereby now your sequence would be given in terms of numbers. Your sequence can also be given in terms of variables. By saying that we can have, this sequence there, whereby now we have the sequence that says t plus 1, t minus 1, 2t minus 5 are the first three terms of a geometric sequence. These three terms are the terms of a geometric sequence. If it is the geometric sequence, it means that we have the constant ratio. The geometric sequence, we have the constant ratio. Now, this question says calculate the value of values of t and hence the possible sequence. The possible sequence, they mean that the sequence should be in terms of values like -5, 10, -20 and 40, meaning that we are first required to find the value of t, and this sequence is said to be the geometric sequence. By saying that the sequence is geometric sequence, if we have these three terms there, the first term, let me rewrite them here, it's t plus 1, the second one t minus 1, and then the third one is 2t minus 5. We have this as our three terms of a geometric sequence. Now, if it's geometric sequence, it has the constant ratio. How do we find the constant ratio of any geometric sequence? Our ratio is equals to term number 2 divided by term number 1. That must be equals to term number 3 divided by term number 2. Now this gives us our constant ratio. Term number 2 divided by term number 1, that is equals to term number 3 over term number 2. Now term number 2 in this case is t minus 1. Therefore our term number 2 would be t minus 1 all over term number 1. Term number 1 is given as t plus 1. T plus 1. This is equals to term number 3 divided by term number 2. Term number 3 there is 2t minus 5 all over term number 2, that is t minus 1. We have this as our ratio. For it to be geometric, this ratio has to be through. This equation has to be through. Term number 2 or divided by term number 1 must be equals to term number 3 divided by term number 2 for it to be a geometric sequence. Now, the only unknown that we have here is that t, and us finding this t would mean that we are now going to be able to find the sequence that is used here. Now let's cross multiply and solve the value of t. T minus 1 multiplied by t minus 1. We can say it's t minus 1, get rid of the fractions, multiplied by t minus 1. The equal sign as it is, this denominator multiplied by that numerator, we are going to have t plus 1 multiplied by 2t minus 5. And then from there we can now apply our FOIL product of two binomials. T multiplied by t would give us t squared. T multiplied by -1 would give us negative t. -1 multiplied by t would give us negative t. Negative t minus t would give us negative 2t. -1 multiplied by -1 would give us positive 1. This is equals to t plus 1 multiplied by 2t minus 5. Again, we repeat the same process that we did here. T multiplied by 2t, we are going to have 2t squared. And then t multiplied by -5 gives us negative 5t. 1 multiplied by 2t would give us 2t. And then negative 5t plus 2t would give us negative 3t. The addition of those two like terms, negative 5t plus 2t, would give us negative 3t, and then negative or positive 1 multiplied by negative 5 gives us negative 5. And then we can group the like terms, or we can transpose these 3 terms this side, or we can take these 3 terms that other side. One way or the other, the answers would be the same. Now let's say we took this 3 terms this other side. We are going to have 0 this side, and then because this t it's positive here, and then that 2t it's also positive there, it's going to be 2t squared minus t. That would give us t squared, and then we have negative 3t there, and then this one would be positive. Negative 3t plus 2t would give us negative t, and then we have positive 1. We also have negative 5. Minus 5 minus 1 would give us negative 6. Therefore the equation that we have now it's 0, that is equals to t squared minus t minus 6. Now we are going to factorize a quadratic trinomial. If you factorize that, we know that we need 2 brackets, 0 that side. The factors of t would be t and t. The factors of 6, or the factors of negative 6, that would give us negative 1. When we add or subtract them would be minus 3 and positive 2. When the last term it's negative, the signs in the brackets are going to be different, and the bigger number, or when the last term it's negative, the signs in the brackets are going to be different, and the bigger number will take the sign of the middle term. That is the factorization that we learned in grade 10. And then in this instance we are going to have t that is equals to 3, or t that is equals to negative 2. There are my 2 values of t. We have solved for t here. We know the value of t, it's either it's positive 3 or the value of t is negative 2. Now let's substitute t here and then check whether it's t positive 3 or t negative 2. Now if we put 3 there, the first term would be 3 plus 1, that is 4. The second term would be 3 minus 1, that is 2. And then the third term would be 3 multiplied by 2, which is 6. Minus 5 would give us 1. Is this sequence 4, 2, 1 a geometric sequence? 1 divided by 2, it's half. 2 divided by 4, it's also half. Therefore this sequence here, it's a geometric sequence. Then let's check with negative 2. If we substitute negative 2 there, we are going to have negative 2 plus 1, that would give us negative 1. And then the second term, we're going to have negative 2 minus 2, or sorry, negative 2 minus 1, that would give us negative 3. And then the last term, we are going to have 2 multiplied by negative 2, which is negative 4. Negative 4 minus 5, which is negative 9. Now let's check, is this sequence a geometric sequence? Negative 9 divided by negative 3, it's positive 3. Negative 3 divided by negative 1, it's also positive 3. Therefore both sequences are geometric sequences for both values of t. That would be that about these questions, whereby now we have a variable there. Now let's check the types of questions that would be asked under this arithmetic and geometric sequence. The types of questions that would be asked under arithmetic and geometric sequence. Let's start first the geometric sequence. Start first with the arithmetic sequence. Arithmetic sequence, we can also have an arithmetic sequence that is asked in terms of x. Now we have the first question there that says question number 2. Question number 2, 2.1 says 3x plus 1. These are the types of questions that we can expect in our examinations. These are from previous question papers. The first one there, it says 3x plus 1, 2x, 3x minus 7 are the first 3 terms of an arithmetic sequence. Calculate the value of x. Calculate the value of x. If we are to find the value of x and we are told that the sequence is arithmetic. Arithmetic and geometric, they differ because arithmetic has a constant difference and geometric has the constant ratio. In this case, we are told that this sequence that we have here is an arithmetic sequence, and we are tasked to determine or calculate the value of x. Now, the first part, for it to be arithmetic sequence, it must have the constant difference. And how do you find that constant difference? Our constant difference is equals to term number 2 minus term number 1. That must be equals to term number 3 minus term number 2. This is how we find the constant difference. Now, what is the value of term number 2 in this given sequence? The value of term number 2 in that given sequence there is 2x. Therefore, term number 2 there is 2x minus term number 1 there is term number 1. Term number 1 is 3x plus 1. This must be equals to term number 3 minus term number 2. Term number 3 there, we are given term number 3 as 3x minus 7 minus term number 2, which is 2x. And then we are tasked to calculate the value of x. And there it's our equation. It is in terms of x. X is the only unknown that we have there. Now, let us subtract then. Now, there is the part where this term needs brackets because it's more than one term. Remember, if you subtract more than one term, you would need to have your brackets. If it's one term, then it doesn't need the brackets. Then it would be 2x minus 3x, negative and positive, negative and positive. It would also be minus 1. This is 3x minus 7 minus 2x. We can therefore group the like terms. All the terms that has x, I can group them on this left hand side, and then all the constants on that other side. And then in this side we have 2x minus 3x. That would give us negative x minus 1 equals to this side we have x minus 7. And then if we transpose this negative x to this other side, it would be negative. Therefore, we are going to have negative 2x, that is equals to, if we transpose this negative 1 that other side, it would be positive. Negative 7 plus 1 would give us negative 6. And then we can divide both sides by negative 2. Divide by negative 2, divide by negative 2. Therefore, the value of x in that question would be positive 3. We now have the value of x. The value of x is positive 3. Because we were told that this sequence is arithmetic. And if the sequence is arithmetic, it has the constant difference. Now, the second question says, the first and second terms of arithmetic sequence are 10 and 6 respectively, meaning we are given term number 1 and term number 2. Term number 1 is 10, term number 2 is 6, and we are told that they are an arithmetic sequence. They form part of the terms of arithmetic sequence. The first term is 10, the second term is 6. Now the question says, the first one, calculate the 11th term of the sequence. Calculate the 11th term, meaning that our n would be 11. The 11th term of that sequence. Now n is 11. We are looking for the term value of term number 11. When we get to term number 11, what is it that we'll find there? What value is there at term number 11? Now, for us to find term number 11, we would again go that long route of ours, or the easier route of ours, of finding the general term first. The general term of an arithmetic sequence, if we have two terms, the two terms that are 10 and 6, because we are told that this is an arithmetic sequence, we are sure that These two terms here, 10 and 6, the difference there would be constant for all the terms that would find there. The difference 10 and 6, 6 minus 10 gives us -4. Therefore, the constant difference there is -4. Now, Tn is equals to A plus n minus 1 by D. N minus 1 by D. The difference is -4. A, the first term is 10. N, the 11th term, we are given n. We are told to calculate the 11th term, meaning that this is our n, and we are looking for Tn. We don't have the term value of the 11th term. Now, A is 10 plus 11 minus 1 by D. D is -4. Now, you can punch this on your calculator, or you can do it stepwise. 11 minus 10, or 11 minus 1, it's 10. 10 multiplied by -4, it's -40. -40 plus 10 gives us -30, meaning that the value of term number 11 would be -30. There is the term value of term number 11. Now, let's continue and check the other questions that can be asked under sequence and series, arithmetic and geometric sequence. We can also have a geometric sequence question. There is our question there. Question 3. Question 3 that says a geometric sequence has term number 3 that is equals to 20, term number 4 that is equals to 40. The first question that we get there is determine the common ratio. Determine the common ratio. And remember, how do we find that common ratio? We said the common ratio is term number 3 divided by term number 2, term number 2 divided by term number 1, or term number 4 divided by term number 3, term number 5 divided by term number 4. You only divide 2 consecutive terms. Term number 10 divided by term number 9. And in this case, we have 2 consecutive terms here. We have term number 3, we have term number 4. These are consecutive terms, therefore we can find our constant ratio. In this case, our constant ratio would be equals to term number 4 all over term number 3. And then our constant ratio would be term number 4 divided by term number 3. And then our constant ratio would be 40 divided by 20. 40 divided by 20 would give us 4 divided by 2, that is 2. Therefore, the constant ratio there is 2 for the sequence that has the third term as 20 and the fourth term as 40. And then there comes that question. Determine the formula for Tn. Determine the formula for Tn, or determine the general term of this sequence. And for us to find the formula for Tn, we are going to need A, which is the first term, and R, of which R we have R is positive 2. Therefore, the only thing that we need for us to find this general term of the sequence that has the third term as 20, the fourth term as 40, we are only going to need A in this case. Tn is equals to AR to the power of n minus 1. And then how do we find A? Because R is there, we are only needing A for us to complete this question, or for us to answer this question fully. Now, the sequence says term number 3 is 20, term number 4 is 40, and then there is a term before term number 3, that is term number 2. There is also a term before term number 2, that is term number 1. We need this term number 1 so that we can have the value of A. We need term number 1. Now, we said earlier on, when we go, or when we take this direction going to the right hand side, we multiply. But when we going on the left hand side, we divide. We divide by constant ratio when we take this direction going to the left hand side, and we multiply by the common ratio when we are going to the right hand side. In this case, 40 divided by 2 gives us 20. 20, because this 2 is constant for all this sequence, or for this sequence throughout. 40 divided by 2, it's 20. We have term number 3. 20 divided by 2, it's 10. Therefore, we have term number 2. 10 divided by 2 gives us 5. Therefore, we have term number 1. Term number 1 is 5. Therefore, the terms that we have there, or that sequence, is 5, 10, 20, 40. That is the sequence there. Then our A is positive 5, which is the first term. Therefore, we are going to have 5 into R. The constant ratio is 2 to the power of n minus 1. There is Tn. Then we have found the formula for Tn. That is 5 multiplied by 2 to the power of n minus 1. And then the last question there, it says, consider the geometric sequence. Consider the geometric sequence for -2, 1. Consider that geometric sequence for -2, 1. And then the question would be, determine the next term of the sequence. The first question there, the sequence is 4. The sequence is 4, -2, 1. Determine the next term of the sequence. For us to find the next term of the sequence, if we are told that it is the geometric sequence, meaning that it has the constant ratio. Now, how do we find the constant ratio? 1 divided by -2, it's -1 over 2. -2 divided by 4, also -1 over 2, and that is constant or common. Now we have our R. Constant ratio is -1 over 2. Therefore, this 1 divided by -2, it's -1 over 2. -2 divided by 4, again -1 over 2. Whatever that we did here, we can also repeat it here for us to find the next term. Remember, we said 40 divided by 2, it's 20. 20 divided by 2, it's 10. 10 divided by 2, it's 5. Now, how do we move going that other direction? 5 multiplied by 2, it's 10. 10 multiplied by 2, it's 20. 20 multiplied by 2, it's 40. Meaning, if we are taking this direction, we multiply. But if we take this direction, we divide. Now, looking for the next term, I am going to multiply 1 by the constant ratio, that is -1 over 2. 1 multiplied by -1 over 2 would give me -1 over 2. Therefore, the constant or the next term of that sequence there would be -1 over 2. That is the next term. Okay, and then the other question there, determine n. If the nth term is 164, determine the term number of which the term value is 1 over 64. Determine n if the nth term is 1 over 64. For us to do that, we are going to need the general term. How do we find the general term? Tn is equals to a r to the power of n minus 1, because we are told that this is a geometric sequence. We are told that this is the geometric sequence, therefore this is the general term of the geometric sequence. Tn is given. We are given that Tn, if the nth term is 1 over 64, meaning that this is Tn. Tn is 1 over 64. That is equals to a. The first term of the sequence is 4. That would be 4 into r, the constant ratio, we have negative 1 over 2, all to the power of n minus 1. N minus 1. Please remember that you are not supposed to multiply this 2. You are not supposed to multiply 4 and negative 1 over 2 and get negative 4 over 2 all to the power of n minus 1. Remember that you are not supposed to multiply, but rather you can divide both sides by 4. Divide this side by 4, divide this 1 over 64 by 4, so that this 4 can cancel out with that 4. 1 over 64 divided by 4 would give us 1 over 256. 1 over 64, if we divide 1 over 64 by 4, we are going to have 1 over 256. 1 over 256, that would be equals to negative 1 over 2 to the power of n minus 1. There comes the interesting part. We have the negative base there, and then we have the positive number here, which is 1 over 264, that is equals to negative 1 over 2 all to the power of 1 or n minus 1. Remember in grade 11 we did the laws of exponents, and then we said any negative number, if we have negative a to the power of odd number, the answer would be negative. But if we have negative a to the power of even number, the answer there would be a positive number, meaning that we can obtain this positive number by saying negative 1 over 2 to the power of any number that is even, then would have 156. But what is that even number that we can place here so that we can have positive 1 over 256? Negative 1 over 2 to the power of positive 8. 8 is an even number, hence it would give us a positive answer ultimately. Then negative 1 over 2 all to the power of 8 would be equals to negative 1 over 2 all to the power of n minus 1. Now that the bases are the same, the base is negative 1 over 2, the base is negative 1 over 2. If the bases are the same, we equate the exponents. Therefore 8 would be equals to n minus 1. Then our n would be equals to positive 9. Then we have found the term number that would have the term value of 164, sorry, of 1 over 64. The term number is 9, meaning that when we get to term number 9 of this sequence here, we are going to have positive 1 over 64. That is that about the geometric sequence. We can have again the other question under geometric sequence. The other question under geometric sequence that has the variable again. That has the variable again. The question says 2.2. Study the geometric series x squared over 3 plus x cubed or over 9. Determine the nth term in terms of x. This series can be, or the sequence can be x. The sequence can be x squared over 3, x cubed over 9. Then there is our sequence. If this is our sequence, and then the question says determine the nth term in terms of x, the nth term in terms of x, meaning that on our nth term we are going to have x as the variable also. Then for us to find the nth term in terms of x, this is the geometric sequence. Tn is equals to ar to the power of n minus 1. Our a, the first term, x, we are only left out with r. How do we find r? Term number 3 divided by term number 2 must be equals to term number 2 divided by term number 1. If we divide this 2, we are going to have x squared over 3 divided by x. X squared over 3 divided by x, the answer would be x over 3. Therefore, our r is x over 3. Substitute r and a there, then would have the nth term in terms of x. Our nth term in terms of x would be a, which is x, into r is x over 3, all to the power of n minus 1. This is the nth term in terms of x. Now, this is basically that about arithmetic sequence and geometric sequence. Arithmetic sequence and geometric sequence. But remember, initially when we started, we said we are going to do sequence and series. That is that about the sequences, the two sequences that we have, which is arithmetic sequence and geometric sequence, and the types of questions that one might expect in an examination. Now let's move to the second part, whereby now the second part becomes the series, so that we can get done with today's session. A series is obtained by adding the terms of a sequence. I'll repeat that again. A series is obtained by adding the terms of a sequence. We have two types of series. It's either a series can be arithmetic series or a geometric series. A series is obtained by adding the terms of a sequence. If we have a sequence 1, 3, 5, 7, this is a sequence 1, 3, 5, 7. For this sequence to be called a series, we must add the terms of this sequence. Adding the terms, we have 1 plus 3 plus 5 plus 7. Now this becomes a series. We can only obtain a series by adding the terms of a sequence. We have two types of series. It's either it can be arithmetic or it can be geometric. Let us start first with arithmetic series. And for the series, the minute you place or you put the positive sign, the plus sign in between two numbers, you know that whatever that we're expecting there, it is a sum. You obtain sum by adding the numbers. Now we have this as a series, and then we can add them, and then we'll have sum of how many terms? In this case, we'd have sum of 1, 2, 3, 4, sum of 4 terms. Now if we are about to find sum of this first 4 terms of this series, because it now has the positive signs, sum of these 4 terms would be 1 plus 3 plus 5 plus 7. There is the sum of these 4 terms. And if we add them, what is it that we have there? We have 7 plus 3, 10, and then we have 16. 16 becomes sum of these first 4 terms. Remember, a series is obtained by adding the terms of a sequence. Adding the terms of a sequence, you have a series, and the minute we add, that process of adding, it's called a sum. We sum it up. We sum those terms up to a single part. Whereby now in this case, if we sum these first 4 terms, we have 16. Now for arithmetic sequence, this can continue. You can be asked to sum up the first 10 terms. You can be asked to find the sum of the first 20 terms, sum of the first 30 terms. Now if this is the case, if we have this sequence there, 1 plus 4 plus 7 plus 10. Now if we find sum of the first 2 terms, it means that we only add these 2 two terms here. This is term number 1, this is term number 2. We are looking for sum of the first two terms, meaning that you are only required to add two terms that are starting that sequence, or that are starting that series. That would be 1 plus 4, meaning that sum of the first two terms in this case would be 5. How did we get 5? 1 plus 4 gives us 5, and then sum of the first three terms means that we add the first three terms. I would add 1 plus 4 plus 7. 1 plus 4 is 5. 5 plus 7 gives us 12. 5 plus 7, it's 6. This one, 6 plus 7 gives us 13. Sorry for that. 6 plus 7 gives us 30. Oh, it's 5 actually. 12. 5 plus 7 gives us 12. Okay, sum of the first three terms is 12, and then sum of the first four terms. Sum of the first four terms, meaning that we add these four terms there. We add 1 plus 4 plus 7 plus 10, meaning that it would be 12 plus 10. 12 plus 10 gives us 22. Then we have summed up the first four terms. But this is easier if your sequence has a limited number of terms. But what if this sequence continues, and then we are required to find the sum of the first 20 terms of that sequence? I know one might be tempted to go up to term number 20 and then add all those terms up from 1 up to 20, or from 1 up to that term number 20 there. But for sum also, we have the formula for sum of an arithmetic sequence, or for summing up the terms of an arithmetic sequence. The formula that becomes Sn, that is equals to n over 2 into 2a plus n minus 1 by d. This is the formula that is used to sum up the terms of an arithmetic sequence. Sn is equals to n over 2 into 2a plus n minus 1 by d. But this formula is examinable, meaning that it can be asked in an examination for you to derive this formula. Sn is equals to n over 2 into 2a plus n minus 1 by d. Now we are going to start, before using this formula in summing up the terms of an arithmetic sequence, we are first going to derive this formula and check where this formula comes from, because that part is examinable and it carries plus or minus 5 marks in an exam. Now let us go through the process of proving that Sn is equals to n over 2 into 2a plus n minus 1. Now the first part, in an arithmetic sequence, you know that a is the first term, meaning that the first term there for all the arithmetic sequence, if we are about to add n terms of an arithmetic sequence, the first term would be a. This is the first term, a, and then remember we said if we are going in this direction, or we are going to the right hand side, we add the difference. If we are going to the left hand side of our sequence, we subtract the difference. In this case, if this is the first term, that is a, the second term would be our a plus the difference. A plus the difference. For example, let's take this as an example there. If we have a sequence that is 1, 3, 5, 7, the first term here is 1 and the constant difference there is 2. Therefore, if I were to write this sequence in this form, I would say the first term is 1 plus, or let me put this, and then the second term is 1 plus the difference. The difference is 2. Therefore, this is a, and then the second term is a plus the difference. And then the third term, I would say it's a, 1 plus 2, which is this term, plus 2, which is the difference. Meaning that how many 2's do we have there? I have 2 2's. Therefore, if I were to write it in this variable form, I would say it is a plus 2d. Now, let's get back here. And then the first term, we said it's a. Because it's sum, I would need the positive sign. The first term is a, the second term is a plus d, the third term would be a plus 3d. And then this continues up to the last term. The last term of an arithmetic sequence becomes the general term of that arithmetic sequence, meaning that our L would be equals to Tn of an arithmetic sequence, and Tn of an arithmetic sequence is equals to a plus n minus 1 by d. That is our L, or that is our last term, or the Tn. Now, if we have the last term as L, the term before the last term, remember we said if we are taking this direction, we add the difference. But if we are taking this other direction, the left hand side, or if we are going to the left hand side, we subtract the difference, meaning that there is a term before the last one, that is L minus d. We subtract difference from this last term to have the term before the last one, and we can also get the term before this last second term. That would be L minus 2d. And then we can do this continuously going back. Remember, it's sum, therefore we are going to need the plus signs there. And then addition is cumulative, meaning that we can start with the last term. 5 plus 2 is equals to 2 plus 5, meaning that we can start with this last term. If we start with the last term, we are going to have Sn, that is equals to L plus. We now rewrite the same process but in the other way. We start with L going back to A. We start with L going back to A, and then we have L as the last term, and then we are going to have L minus D plus, we are going to have, this is 2D, we are going to have L plus, L minus 2D, and then this continues because there are terms before that, plus, and then we have this one, which is A plus 2D, and then we can also have our A plus D, and then we can also have our A. There it's our two sequences. Now, what motivated or what influenced this writing here? What influenced me starting with L, starting that direction to here, starting with L up to A? This is where we get the influence. Let's say we are summing up these terms, Sn, that is equals to sum of these terms, 3 plus, let's say we have 5 plus 7 plus 9. What is the sum of these four terms there? Sum of these four terms there, we have 10, 15, we have 24. The sum of these terms there is 24. If we start with 3, how many terms do we have there? 1, 2, 3, 4. We have 4 terms there, and if we add all these 4 terms here, we are having 24. Now, if I were to start with 9, because addition is cumulative, I would say Sn is equals to 9 plus 7 plus 5 plus 3. The 2 would still give me 24. 9 plus 7, it's 16. Plus 3, it's 19. Plus 5, it's 24. The same number that I got above there. Now, I would obtain 24 using the method that we're going to use when we have the variables there. If I would say this is my first equation and then this is my second equation, because we have two equations there. Now if I were to add the two equations, equation 1 plus equation number 2, if I add the two equations, we have Sn plus Sn, that gives us 2Sn, that is equals to 3 plus 9 gives us 12. 5 plus 9 gives us 12. 7 plus 5 gives us 12. 9 plus 3 gives us 12. This process continues. Okay, this gives us our 24. Now, how many 12s do we have? We have how many 12s? 1, 2, 3, 4. Therefore, this can be 4 multiplied by 12 because we have 4 12s there. This is equals to 2Sn. Now, I can divide both sides by 2. Divide both sides by 2, this 2. Divide by 2, divide by 2. Then our Sn would be equals to 4 divided by 2, it's 2. 2 multiplied by 12 gives me 24. Gives me 24. The same 24 that we had when we added all those terms there. 3 plus 5 plus 7 plus 9. Now, with this process in mind, we can now attempt to do it when we have the variables. Remember how we obtained 24 that other side. We started with 9 going back to 3. We started with 9 going back to 3, and then we did the same here when we have the variables. Now we set Sn plus Sn because we have two equations here. This is equation number 1, this is equation number 2. Now add the two equations. We have Sn plus Sn, that gives us 2Sn. This is equals to A plus L gives us A plus L, and then adding these two, our differences would cancel. This is positive D, this is negative D. We would be left with A plus L again. A plus L, and then here this positive 2D would cancel this negative 2D. We would be left with A plus L. We also have A plus L plus, and then here 2D, it's negative there, 2D, it's positive here. We have A plus L. Add the 2, we have A plus L. D, it's positive there, D, it's negative there. They can cancel out because we are adding these two equations, equation number 1 plus equation number 2. Then we are having A plus L again, and then lastly the last term would also be plus A plus L. Now whatever that we did here, we added the 2. We said we have 4 12s, hence we said 4 multiplied by 12 because we only had 4 terms there. We had 1, 2, 3, 4, hence we said 4 multiplied by 12 before we divided by this positive 2. The same procedure can be applied here. How many A plus L's do we have? We have A plus L's, but how many A plus L's do we have? We don't know how many A plus L's do we have, but we can say there are n times of A plus L's that we have there. Our A plus L's, there are n A plus L's there. For whatever the term number that it would be multiplied by A plus L. If let's say there are 5, it would be 5 multiplied by A plus L. If we say we have A plus L's that are 10, it would be 10 multiplied by A plus L. This n represents the number of terms that we have here, but in this case, because we have the last term as the general term, we can say we don't know, we have n number of A plus L's. N, we multiply it with A plus L, and then this is 2 multiplied by Sn, and then whatever that we did here, we divided both sides by 2 to obtain that 24. We are going to do the same again here. We are going to divide both sides by 2. If we divide by 2, our 2 and 2 would cancel. We are going to have our Sn as n over 2 into A plus L. Now this is the formula that is used to sum up the the terms of an arithmetic sequence. Summing up the terms of an arithmetic sequence, the formula would be Sn, that is equals to n over 2 into a plus l. But remember, what is l? L is a plus n into, or a plus n minus 1 by d. Now where we see l, we can substitute that. Therefore the equation would be n over 2 into a plus l. L is a plus n minus 1 by d. That is our L. From here up to there, this is our L, which is the last term of an arithmetic sequence. Now we have a plus a there. We can add the two a's because they are the like terms. N over 2 into 2a plus n minus 1 by d. Now a plus a gives us 2a. Now this is the formula that is used for us to have the sum of the terms in an arithmetic sequence or arithmetic series, because a series is obtained by adding the terms of a sequence. Now this is the formula that is used. Now both formulas can be used. This one can only be used provided that we have the last term. This one can be used in both scenarios, whether we have the last term or we don't have the last term. But this one can only work provided that we have the value of the last term. Let's say, for instance, we have this sequence here. The sequence is 2, 5, 8, 11. We have the sequence here. We have 4 terms in this sequence. This becomes a series if we add. Let's say we have this series here, 2, 5, 8, and 11. The series that we have, it's an arithmetic series because it has the constant difference. Our constant difference is positive 3. If we subtract the 2 there, we have positive 3. Now, if we are to find the sum of this series, the formula or these two formulas would be applicable because we have the last term here. The last term here is positive 11. Therefore, we can find the sum of this series. Remember, it becomes the last term because there are no dots after the last term that shows that this series continues after this last term. Because there is nothing after this last term, this term becomes the last term. Now, how many terms do we have here? 1, 2, 3, 4. Meaning that we are required to sum up these 4 terms. Meaning that we are required to find sum of the first 4 terms. And sum of the first 4 terms by just looking at this equation here. These numbers here. 2 plus 5 plus 8 plus 7 gives us 26. Now, if we are to find this using one of these two formulas, let's start first using this one because we have the last term. Sum of the first 4 terms would be equals to n over 2 into a plus l. Our a is the first term, l the last term. A first term, l last term, n the number of terms that you are adding up. Therefore, this would be 4 over 2 because there are 4 terms there into a, the first term is 2 plus the last term, which is 11. 2 plus 11, it's 13. 4 divided by 2, it's 2. 2 multiplied by 13 gives us 26. Therefore, sum of the first 4 terms there is 26. But if this sequence has that plus sign there and then the 3 dots, it shows that the sequence is continuing after the term 11 or after the 4th term. Now, if the sequence is continuing after that, we are not going to be able to use this sequence or this formula that has the last term. But let's say, for instance, we were required to find sum of the first 20 terms of this sequence. 20 terms of the sequence, meaning that you add all those terms up to term number 20. You add the terms up to term number 20. But the easier way would be for you to use this formula or this one because it sums up all the terms that you want to add in an arithmetic series. S20 would be equals to n, which is n over 2, and then 2a plus n minus 1, all multiplied by d. And then our n, the number of terms that you are adding, it's 20, because we add 20 terms there. Therefore n is 20 all over 2 into 2a. The first term that we have, the first term there is 2. Therefore this is 2 plus n, which is 20 minus 1, and then the difference between the two terms there is 3. And then punching this on your calculator, you'd have found the sum of the first 20 terms of this series. Now let's have the examples under arithmetic series. The first example that we have under arithmetic series says, find the sum of the first 20 terms of this series. Find the sum of the first 20 terms of this series that we have here. The sum of the first 20 terms, the series is -1 plus 3 plus 7. Sum of the first 20 terms. Now, is this series an arithmetic or geometric series? Though we have not yet dealt with the geometric series, this is an arithmetic series because it has the constant ratio or constant difference of +4. +4. 7 minus 3, it's 4. 3 minus -1, it's 4. Therefore, the constant difference there, it's +4. We have d is equals to 4. We have a, the first term, it's -1. We have n. We are told that to find the sum of the first 20 terms, meaning that we add 20 terms. This is n, is 20. And then we are looking for the sum, S20. We are looking for that sum. And then the formula is Sn, that is equals to n over 2 into 2a plus n minus 1 by d. Why am I using this formula? Because we don't have the last term there. This series continues. We don't have the last term. Then this formula becomes applicable. And then n, we are given n as 20. Therefore, we are going to have 20 over 2 into 2a. A is -1 plus n, or which is 20 minus 1. The constant difference there is 4. Now you can punch this now on your calculator. You would have the sum of the first 20 terms of this series, that is -1, 3 and 7. Sum of the first 20 terms of this series would be 740. If you were to punch this in your calculator, this is 20 here. Yes. Okay, and then the second example. The second example that we have would be this example here, example number 8, that says calculate the sum of the following finite series. The series is finite. We have 3, 5, 7, and then it goes up to the last term, which is 111. And then you are asked to calculate this sum. Now, for us to calculate sum, we are going to need the number of terms that we are adding there. That would be the first task, for us to find the number of terms, because we can't add the number of terms of which we don't know the number of terms that we are adding. We first have to find n, so that we can know that we are adding this number of terms. And then if this is the arithmetic sequence, and then the sequence is let me do this. The sequence is, series is 3, 5, 7, and then it continues up until it gets to 111. Now, Sn is equals to n over 2 into 2a plus n minus 1 by d. Now sum, the question said calculate the sum of the following. Now for us to find the sum, we need to have n, because in this case we have a, it's positive 3, d, it's positive 2, we have a and d, we are missing n. We are going to look for n first. Now how are we going to find n? This is an arithmetic series. For all arithmetic series, the last term it's given, meaning that we are given the tn. Remember we said last term it's tn. Tn is equals to a plus n minus 1 by d. N minus 1 by d. Tn, the term that we are looking for, or we have the term value, we don't know the term number. The term value is 111. We are looking for the term number of this value. Therefore this would be 111. That is equals to a, the first term is 3, plus n minus 1. We said the constant difference is positive 2. Now solve for n there. Solve for n. If we solve for n, we are going to have 2n, and then it's minus 2, and then we have that would give us 2n plus 1, because negative 2 plus 3 would give us positive 1, and then this is 111. Transpose this positive 1 this side, it becomes negative. We are going to have 110, and that is equals to 2n. Dividing both sides by 2, we have our n as 55, meaning that this question that said calculate the sum of the following finite series, we were actually calculating the sum of the first 55 terms, because there are 55 terms from 3 up to 111. The terms there are 55, meaning that we now have n. N is 55. Now we can substitute n this side so that we can find, or we can answer the question, calculate the sum. N is 55. We have 55 over 2 into 2a is 3 plus 55 minus 1 multiplied by the difference, that is 2. Now we can punch this on our calculators, and if we punch that on our calculators, we are going to have 3135 as the sum of the first 55 terms of this series, 3, 5, 7 up to 111. Like the sequences, series also have two types of a series. It's either a series, it's an arithmetic series, or an geometric or exponential series. These whole examples that we have been dealing with now are for the first part of the series, of which it is the arithmetic series. Let us now move to our last part of the day. That would be the geometric series. Geometric series is obtained by adding up the terms of a geometric sequence. A geometric series is obtained by adding up the terms of a geometric sequence. Now let's say we have this geometric sequence here, 2, 4, 8, 16. 2 multiplied by 2 it's 4, multiplied by 2 it's 8, multiplied by 2 it's 16. Therefore this is an geometric sequence. But because of this plus signs, it now becomes a series, because we are adding up the terms of a geometric sequence, and then we obtain a series. Now let's use this as our example. A geometric series also has the general or the formula for sum. Let's start first by using this. sum of the first two terms of this sequence. Sum of the first two terms of this sequence, meaning that we only add term number 1, term number 2, and then we have term number 3, and then we have term number 4. The sum, series, adding, and then if you add, meaning that you have what? A sum. Now 2 plus 4 gives us 6, meaning that we have only added the first two terms, term number 1 and term number 2, and then we can get sum of the first three terms. Sum of the first three terms, meaning that we add term number 1, term number 2, term number 3. If we add them, we are going to have 14. 8 plus 4, it's 12, plus 2, it's 14. And then we can also have sum of the first four terms, meaning that we add these four terms. 2 plus 4, 6, plus 16 plus 8. If we add them all, we are going to have 30. Sum of the first four terms there is 30. We can obtain this 30. Remember how we derived, or how we came to the formula of some arithmetic series. We said Sn is equals to, the first term is A. The first term is A. Sn would be equals to A plus the second term of a geometric sequence, because the nth term is Tn, that is equals to AR to the power of n minus 1. The first term would be A. The second term would be AR, because we multiply by ratio, and then the third term would be AR squared, and then the fourth term would be AR to the power of 3. This also continues up to the last term. The last term of a geometric sequence would be that general term. The last term would be AR to the power of n minus 1. There is our last term. Now we are going to derive the formula for sum of a geometric sequence. Now let us start first by looking at it with numbers before we can deal with the variables, so that we can understand the process. First with the numbers. Now if we have a sequence or a series 2 plus 4 plus 8 plus 16, the sum of these four terms there is 30. 16 plus 4, it's 20, 8 plus 2, it's 10, 20 plus 10, it's 30. Now this is our Sn. This is sum of the first four terms. Now, because this is a geometric series, we obtain the second term by multiplying the first term with r. Now, we obtain this 4 by multiplying the first term with r, and in this instance, our r is equals to 2. And we can multiply both sides by that 2. Remember what you do on the left hand side, you also do it on the right hand side. If you multiply both sides by 2, we are going to have 2Sn. That is equals to, I multiply this first term by 2. 2 multiplied by 2 gives me 4. But 4 in this series is the second term, meaning that if I multiply 2 by 2, I'm going to have 4. 4 multiplied by 2, I'm going to have 8. 8 multiplied by 2, I'm going to have 16. 16 multiplied by 2, I'm going to have 32. And now there is my series. If I multiply this series by 2, I am not going to have the first term on this series, because if I multiply the first term with r, I am obtaining the second term. Now we can subtract the two equations. Remember the sum of this, we are going to obtain that 30 even if we are doing it in this method. Add or subtract the two equations. If we are to subtract the two equations, I would say 2Sn minus Sn. This second equation minus that first equation, and then remember here it's 0, and we also have 0 there. 4 and 4 would cancel out, 8 and 8 would cancel out, 16 would cancel out. I would have Sn, okay, this is equals to 0 minus 2, I would have negative 2, and then 32, and that I would have plus 32. And then negative 2 plus 32 gives me 30. And then 2Sn minus Sn gives me Sn. Therefore, sum of these terms gives me 30. Even if I'm doing it in this long way, I'm going to have 30 still. I'm going to use this process to derive the formula of obtaining sum of the first n terms of a geometric sequence. Have this picture in mind. Sn is equals to 2 plus 4 plus 8 plus 6, and then multiply both sides by 2. 2Sn would be equals to 4, 8. We multiply each term by 2, and then we obtain this. And then this process is going to be very, very important for us to obtain the formula for sum, because we have Sn is equals to A. In that instance, our A was 2 because A was the first term. AR squared, this goes up to the last term. Our last term, the general term. But there is a term before the last term. The term before the last term would be AR to the power of n minus 2. And then there would also be a term before that, that would be AR to the power of n minus 3. How did I obtain this? I'm taking this last term divided by ratio, we get this. This second last term divided by ratio, we have that. Now apply the knowledge that you have gained there when we dealt with the numbers. We multiplied both sides or all terms by the ratio, because this has the constant ratio. If you multiply all sides by or all terms by ratio, we have Rsn, that is equals to the first term multiplied by ratio, because we multiply all terms by r, which is the constant ratio. If we multiply a by r, you are not going to obtain a, but we're going to obtain ar. Then we have our ar there. And then multiply this term, or sorry, this second term by r, we have our ar squared, plus we can multiply all terms there by r. And then if you multiply the term before this by r, we are going to have ar to the power of n minus 3, plus if you multiply ar to the power of n minus 3 by r, we are going to have ar to the power of n minus 2, plus, and then we have ar to the power of n minus 1. The last one, ar to the power of n minus 1, if you multiply it by r, we are going to have ar to the power of n. And then we do the same process that we did there. Subtract the two equations. Equation 1, Sn, equation 2, Rsn. Subtract those two equations. If you subtract the two equations, we'd say equation 2 minus equation 1. Subtract them, we have Rsn minus Sn. Because there is no term here, I am allowed to put 0. Because there is no term there, I can also put 0 there. Now, 0 minus a would give us negative a. Ar minus ar cancels out. Ar squared minus ar squared cancels out, meaning that all these other terms would cancel out. All these other terms would cancel out because they are similar. Would only be left with ar to the power of n. Then this is plus ar to the power of n. And then there is a common factor this side, which is Sn. Take Sn out, we are left with r minus 1. This side, we can rewrite it, or we can take a out as the common factor as well, because we have a as the common factor there. We can have a into positive ar to the power of n. I can have r to the power of n. A multiplied by r to the power of n gives me positive ar to the power of n, and then minus 1 for that last a there. A multiplied by negative 1 would give me negative a, and then I can divide both sides by r minus 1. Sn is equals to a into r to the power of n minus 1 all over r minus 1. This is the formula then that is used to sum up all the terms of a geometric series. The formula is Sn, that is equals to a into r to the power of n minus 1 all over r minus 1. This formula is used to sum up all those terms. Now we can use the same formula to find sum of these 4 terms there, but now using this formula. And then sum of the first 4 terms there would be S4, that is equals to A. The first term of our sequence there was positive 2, then our A is 2 into the constant ratio there. Our constant ratio of this series, if we say 16 divided by 8, it's 2. Therefore our r is 2. We are going to have 2 to the power of 4 minus 1 all over 2 minus 1. If you punch this on your calculator, you are going to have the answer as positive 30. This is the formula that is used to find sum of the terms in a geometric series. We also have the formula that we have just dealt with now, Sn, that is equals to n over 2 into 2a plus n minus 1 by d. This one is used for geometric series. This one is used for arithmetic series, and we have proven both of these formulas because they are important for you and they are examinable. They can appear in 1 or 2 exams this year, one of these 2 equations. Now let's have the examples under this geometric series, whereby now we are requested to find the sum. We can start first with this question here. Okay, example number 9. Example number 9 says find the sum of the first 12 terms. Find the sum of the first 12 terms of this series. Find the sum of the first 12 terms of the series, and the series is 2 over 3 plus 2 plus 6 plus. These 3 dots means that this series continues. The 3 dots here shows that the series continues. Now let's have the series written here. It's 2 over 3, it's 2 plus 6 plus, and then the series continues. We are requested to find the sum of the first 12 terms. Now what kind of a series is this? Is this an arithmetic series or geometric series? For it to be arithmetic series, it has to have the constant difference. For it to be geometric series, it has to have the constant ratio. Now let's check. 6 divided by 2 is 3. And then 2 divided by 2 over 3, it's also 3. Therefore this 3 is our constant ratio. This series, it is the geometric series because it has the constant ratio. Now for a geometric series, we can only find the sum of the first 12 terms by saying Sn is equals to a open bracket r to the power of n minus 1 all over r minus 1. Now there comes the tricky part again, whereby now our most learners are making mistakes. This is r to the power of n minus 1, not r to the power of n minus 1 in this form. Our negative 1 doesn't form part of the exponent. Our negative 1 is not part of the exponent. This is incorrect. Please bear in mind, please remember that negative 1 doesn't form part of the exponent. It's r to the power of n minus 1. Negative 1 not part of the exponent. Okay, let's move on. We are requested to find the sum of the first 12 terms. Sum of the first 12 terms. Now our n is 12. Therefore a is 2 over 3 into r, that is, we said r is 3 to the power of 12 minus 1. Close bracket, all over 3 minus 1. We have substituted a is 2 over 3. We have substituted r, the constant ratio is 3. We have substituted n. We were told to find the sum of the first 12 terms. Therefore our n is 12 minus 1 of the formula. Then if you punch this again on your calculator, you are going to have 177 146,67 177,146,67. This would be the sum of the first 12 terms of this series. If this series continues up to term number 12 and you add all those terms, your sum would be 177,146,67. That was example number 9. And then the last example of the day would be calculate the sum of the following finite series. Calculate the sum of the following finite series. There is our finite series: 0,25, 0,5, 1, 2, up to 256. And we are requested, or we are required, to find the sum of that series. Remember, you cannot find the sum if you don't know the number of terms that are involved in that series. The first part would be for us to have the number of terms that are added up so that we can calculate the sum. Now, the formula or the series is 0,25, 0,5, and then after 0,5 we have 1, we have 2, we have 2, 5, 6. Now this is our series. Find the sum of this series. I cannot find the sum before I know 256. It's which term is 256? Is 256 the term 10? Is 256 term 11? 256 term 12? So that I can find the sum of those terms. Now first get the term number of which the term value is equals to 256. First get the term number of which the term value is 256. How do we find the term number? This is the geometric series. Therefore, for geometric series, we're still using that general term. Tn is equals to ar to the power of n minus 1. Tn, we have the term value. The term value is 256. That is equals to a, that is the first term. The first term is 0,25 multiplied by r. How do we find the ratio? 2 divided by 1 is 2. 1 divided by half is 2. Half divided by a quarter is 2. Therefore, our constant ratio would be 2 to the power of n minus 1. Now, solve for n. Remember the golden rule here. You are not supposed to multiply 0,25 by positive 2, but rather divide both sides by 0,25. If we divide this side by 0,25, we divide this side 0,25. 0,25 cancels 0,25, and then we have 256 divided by 0,25. That would give us 1024. 256 divided by 0,25 is 1024. That is equals to 2 to the power of n minus 1. Now 1024, it's 2 to the power of a certain number, so that we can have the same basis. If the bases are the same, we can equate the exponents. Now if we have this as the number 1024, this can be rewritten as 2 to the power of a certain number, that is equals to 2 to the power of n minus 1. It's 2 to the power of how much? That would give us 2 or 1024. That would be 2 to the power of 10. 2 to the power of 10 is 1024. If the bases are the same, we equate. If the bases are the same, we equate the exponents. Now, therefore, 10 would be equals to n minus 1. Transpose this one this side, we have 11, that is equals to n. Therefore, 256 is term number 11. Therefore, in this question, we are required to find the sum of the first 11 terms of this geometric series. The geometric series is 0,25, 0,5, 1, 2, up to 256, which is term number 11. Now, for us to find the sum of those terms, we can say Sn is equals to a into r to the power of n minus 1 all over r minus 1. And then a, the first term is 0,25 into r is r is positive 2. Therefore, we are going to have 2 to the power of 11, which is that n minus 1 all over r minus 1, which is 2 minus 1. And then we can punch this on your calculator. 0,25 into 0,25 into 2 to the power of 11 minus 1 all over 2 minus 1. Punching that on the calculator, we're going to have 2047 over 4. 2047 over 4. Or if you write it in the decimal form, you're going to have 511,75. This is the sum of the first 11 terms of this series. Now, that is basically that about the sequence and series. We have questions here. We have the questions here of sum of arithmetic and geometric. They are also examinable. You can meet this question in an exam. Let's check the first one that we have under the sum. The first question, yes, the first question would be our question 4.1.3. That's how these questions are examined in an exam. Calculate the smallest value of n, for which the sum of the first n terms of the sequence would be greater than 10,140. They would be greater than this. Now, it's not always the case where you will see or you'll meet the questions that are straightforward as this, whereby now you'll have to find the sum of the first 12 terms, or you'll have to find the n of an infinite series, and then we'll find the sum. Some questions will be required to find the smallest value of n, for which the sum of the first n terms of the sequence would be greater than. Now, based on the information that we have, we are given that this is the series, arithmetic series, -8, -2, 4, and 10. There are my 4 terms. This is an arithmetic sequence. And then we are going to determine the smallest value of n, for which the sum of the first n terms of this sequence would be greater than this. Now, the first term that we have there, these are the questions that are a bit difficult, but if you practice frequently, or if you practice them more regularly, you would get to understand them deeper. And then let's have our series. Our series is -8, and then -2, and then +4, and then +10. There is our series, -8, -2, +4, and +10. Now, the constant difference here, it is an arithmetic series. The constant difference here, it's 6. The constant difference here is 6. 10 minus 4, it's 6. 6 minus -2, or sorry, 4 minus -2, it's 6. And so on. And then let's do it here. Okay, and then Sn is equals to n over 2 into 2a plus n minus 1 by d. And then Sn, okay, n, for which calculate the smallest value of n. We are solving for n. The smallest value of n, meaning we are calculating for n. Sum of the first n terms of the sequence would be greater than our n over 2 into 2a plus n minus 1 by d would be greater than 10,140. And then we are solving for this n. Our a, it's given, the first term, it's -8. Our difference is there, it's +6. And then the only unknown that we have would be n. And then n over 2 into 2a, a it's -8, plus n minus 1 by d, d it's 6. This would be greater than 10,140. And then from there we are solving for n. Solve for n, multiply both sides by 2. If you multiply both sides by 2, we are going to have n into 2 or multiplied by -8 plus n minus 1 by 6. Multiply this by 2, we are going to have 20,280. Multiply by n or get rid of or multiply the bracket inside the bracket, n into this is -16, and then this would give us 6n minus 6. This is greater than 20,280, or this is plus. And then multiply by n throughout. We are going to have -16n plus 6n squared minus 6n, that is greater than 20,280. Okay, and then the like terms there, we have -16n. We also have -6n. -16n minus 6n gives us -22n. We have 6n squared minus 22n. If we transpose this other side, it would be minus 20,280. That is greater than 0. And then from there, we can now divide all terms by 6. 22 if we divide it by 6. 22 if we divide it by 6, we have 11 over 3. Therefore, this side we can have our n squared minus 11 over 3n, and then we can divide that 20,280. We can divide it by 6 as well. Divide it by 6, and then if you divide by 6, we have minus 3,380. That is greater than 0. And then we can look for the factors. We can look for the factors, and then we are going to have two values of n. But remember, n will never be a negative number, and n will never be a fraction. N can never be a negative number, and n will never be a fraction. Now let's calculate the values there. Let's quickly punch this. Our value of a is 1. Therefore, we are going to have we can say n is equals to -b plus or minus the square root of b squared minus 4ac all over 2a. And then we can punch the value of a, b, and c. We can punch the value of a, b, and c. A would be let me just continue up here. Our a is 1. B would be -11 over 3, and then c would be -3380. And then we have those values there. Then we can punch it on the calculator. A it's negative. Okay, negative b, b it's -11 over 3, negative 11 over 3 plus, and then we have the square root of b squared, which is negative 11 over 3 all squared, minus 4a is 1, and then c is negative 3380, close bracket, all over 2a, and then we say equals to, and then the first one we have there, we have n as equals to 169 over 3, or the second n would be, the second n would be 60. Therefore, the two values of n there, n is equals to 119 over 3, or n is equals to positive 60. We have the two values of n, therefore the smallest value of which, this is negative 60, the smallest value of which n would be greater than this number would be the number, the smallest value there would be n, therefore n would be 56, because negative or positive 119 over 3 is 56,3333. Therefore the first number there would be 50 or greater than, therefore it would be 57. N is 57. Therefore that would be basically that about today's presentation, sequences and series. We started first by dealing with the sequence. What is a sequence? A sequence and then a series. And then we said a sequence is a set of numbers written in particular order, and then we said a series is obtained by adding up the terms of a sequence. That would be basically that about today's session. I thank you.